We now need to learn how to differentiate one enantiomer from another in terms of its name. Let's start with this chiral carbon. What we're going to use is called the Con-Ingold Prelog system. And this is going to be a way that we designate what's called the configuration of the carbon. And the configuration can be either what's called R or S in nature. And the first thing we're going to do is to identify the four groups about the chiral center. So we obviously have hydrogen, bromine, chlorine, and fluorine. Then we need to prioritize them. And we're going to do this by simply just the molar mass of the atom that's directly connected to the carbon. So the higher the molar mass, the higher priority it gets in this system. So the highest molar mass between these four atoms that are circled is going to be bromine. So it's going to get priority 1. Chlorine is going to be priority 2, fluorine is 3, and hydrogen, of course, is 4. And notice that the way I have this drawn, group 4 is facing away from me. So if I'm looking at the carbon, group 4 is going towards the back. It's going away from me. And that's the way that you want to get these molecules oriented to be able to use this Con-Ingold Prelog system. In terms of R or S, what we have here is with group 4 going away, we notice that there's a counterclockwise orientation of groups 1, 2, and 3. And so we would give this what's called the S designation. So we already looked at the S configuration on the left. Now if we draw the enantiomer of this structure, which is on the right, you're going to see that you get the exact opposite configuration. The groups 1, 2, and 3 are now going in the clockwise direction. So this gets the designation R. And that's always going to be the case for two enantiomers. If one is S, the other one is going to be R. They're always going to be opposite in configuration. Now to incorporate this R or S designation into the name of the molecule, you simply just insert it into the beginning, and a lot of times it's going to be the R or the S will be in parentheses. I didn't have it that way here, but that's not uncommon. And you don't know how to name an alkyl halide like this yet, but you will soon, and you will see that you're going to come across this R and S designation at the beginning to tell you which enantiomer you are looking at. But what if the molecule would have been drawn from this orientation, with group 4 actually not facing away from you? How are we going to deal with that? That's what we need to look at. So when group 4 is not facing the way that you need it to face to be able to assign R or S configuration, there's kind of 3 strategies that I generally will instruct students to use, and usually one of the 3 strategies will work. Sometimes it takes a little practice with a model kit to be able to then get good at doing it on paper. But the first of those is to just try to visualize what it would look like if you were looking at it from the angle of group 4 facing away. So that would be the way, the angle that the green arrow is drawn on this particular slide. And some people are very good at seeing that if group 1 is here, I go into the board to group 2 and come back out of the board for group 3, and that I'm going in a clockwise direction. So this would be designated as an R configuration. If that first strategy doesn't work for you, that's fine. Here's another strategy you might want to try, and that would be to rotate hydrogen to the back. And so if you could picture, I have an axis drawn in an orange dashed line here, and if we want to rotate group 4 to the back, we could rotate about that particular axis, and that would get hydrogen to the back position, and then you could just assign from there. If you flip the hydrogen to the rear position, that's going to bring the chlorine out to the front position, the bromine off to the right and the fluorine off to the left. And then you can just do the analysis. 1, 2, 3, you see that it's going in the clockwise direction. So again, we're coming up with the R configuration. Finally, the third strategy you could try is to swap two groups and then the other two groups. And I have that second part underlined because this is where you can mess yourself up if you forget to do the second swap. So if we have group 4 here and we want to have it in the back, we can simply just switch these two groups around. So we've put hydrogen where chlorine was and chlorine where hydrogen was, but the thing we have to remember to do then is then to also swap the groups up here so that we bring bromine off to the right and fluorine off to the left. If you forget to do that second swap, you will come up with the wrong answer to the question because you're actually going to end up drawing the mirror image to the structure when you do that first swap. So if you do it again this way, you're going to come up with the 1, 2, 3 clockwise orientation or the R configuration. This time let's take a look at what to do when the groups are not all just one atom. So we've looked at this molecule a few times with bromine, chlorine, hydrogen, and a methyl group. And anytime hydrogen is going to be present, it's going to be group 4 because there cannot be anything with a lower molar mass than hydrogen, right? But then we have to decide between bromine, chlorine, and then a methyl group. And I boxed in the carbon in yellow because you're really only comparing that first atom that's connected to the carbon, the chiral carbon. And so we are directly comparing bromine, chlorine, and carbon in this case. And so we've come up with this 1, 2, and 3 priority. Now you can see what I've done. I've just redrawn the structure without the groups on it because once you've done the 1, 2, 3, 4 assignment, you don't really need those groups on there if you don't want. And so some people like to simplify the drawing and just put the numbers where they belong and then try to get group 4 to the back because right now it's off to the right side. If I use the first strategy, which some people like to do, you can see that you go in on 1, you come out on 2, and then down on 3. So again, you're getting this clockwise rotation or the R configuration. If you don't like that, you can try rotating it. This time we're going to rotate it about the axis shown here so we can flip 4 to the back. If you do this, you're going to bring 4 backwards, and then you're going to bring 1 forwards and 2 down to the bottom. So sometimes that's a little tricky to see if you don't have a model kit in front of you, especially when you're not used to thinking about these drawings going back and forth from 2 dimensions to 3 dimensions. And so practice doing that if you would like, if you prefer to do this rotation method. And then finally, here's the swapping method, which I think works well for a lot of people who can't visualize this stuff in 3D. You just have to be careful to do the second swap. So we want 4 and 1 to switch in the first swap, but then we have to remember to switch 2 and 3 to come up with the correct answer. So as long as you remember to do that second switch, then you should be fine. Again, you're coming up with a clockwise rotation and R configuration. We saw this structure in the last video. Now what I want you to do is to pause the video and try to use one of the 3 strategies that we've discussed to decide if this particular molecule is R or S in configuration at the chiral center. And hopefully you were able to come up with the counterclockwise rotation this time, and this has the S configuration. Let's look at one that's a little bit more complicated. It's pretty easy to tell that group 1 is bromine and group 4 is hydrogen, but then we don't know how to handle this and this since they both have 2 carbons there. How are we going to prioritize those? So when you have a double bond, you're going to treat it shown here, as shown here. And so I'm going to go ahead and draw in the other hydrogen here. But we're going to compare atom by atom when you go out away from the chiral center what you encounter. So we encounter carbon and carbon first. Then if we look out again, we encounter carbon and carbon this way. Okay, so right now it doesn't look any different. But if you go here, you see you have hydrogen, hydrogen, where on this carbon over here, we have hydrogen and carbon. When we're doing the prioritizing, we treat it this way. And so this is going to take a higher priority. We're going to give that priority 2, and this group is going to take priority 3. And so hopefully you're able to see that once you've numbered these 1, 2, 3, and 4, that you are going to come up with the R configuration. Similarly with a triple bond, you're going to treat it sort of the same way. For each pi bond, you are putting an extra carbon on each atom. So this time you have 2 pi bonds, and so you're going to put 2 carbons on there in terms of just the way that you treat it when doing the prioritizing. So it's obvious that fluorine takes top priority and hydrogen takes bottom priority. If we go out in both directions here, we see carbon and carbon. But then again, once you go out further, you have hydrogen, hydrogen, and down here you have carbons. And so once again, this is going to be a higher priority. We're going to give this priority 2, and this one's going to be priority 3. And hopefully you were able to see that you get this counterclockwise rotation, and so you have the S configuration about this chiral center.